Hello everyone, welcome to part 3 of paper 1, question 18. Tick this sign to show if each of the calculations is equivalent to 37 times 10 to the power of negative 3 or not. So this is the first calculation. So 3.7 times 0.01, okay, so it's the same as 3.7 divided by 100. Okay, so they are the same. So if you divide by power of 10, as you already know, you have to shift the decimal point backward. So from 3.7, so if you divide by 100, so we need to shift this backward 2 times, 1 and 2. So the decimal point is now here, so you can fill up this with a 0. So that means this is the same as 0.037. Okay, so if you want to write this as in standard form number, okay, so it has to be from here, okay, according to what you have here. So 37, so you have the decimal point here. So let's count 1, 2 and 3. So that will be 37.0 or 37 times 10 to the power of negative 3. So this is equivalent to this, okay. So for the second one, you have 3.7 times 10 to the power of negative 2. So you can rewrite this as 3.7, okay. So you can write it as ordinary form. We are multiplying by power of negative 2, 10 to the power of negative 2. So that means you have to shift the decimal point backward 2 times, okay. So that will be 3.7, then you can now shift it 2 times, 1, 2. So we shifted it backward because of negative 2, okay. So if you have positive 2, then you have to shift it to the front. So the decimal point is now here, so you can fill up this with 0. So that means this is the same as 0.037. So if you want to write it as this, okay, so that means you have 1, 2 and 3, okay. So this will be 37 times 10 to the power of negative 3. So you can check this. And the third one, to write this one, okay, so as ordinary form, it will be okay, so you already know you have to shift the decimal point backward 4 times from here. 1, 2, 3, 4. Okay, so the decimal point is here. You have 0, 0, 0. So that this will be equivalent to 0.00037. So if you want to write this to be in this form, so that means you start from here. 1, 2, 3, 4 and 5. So this will be 37 times 10 to the power of negative 5, so which is not equivalent. So we check this one. And the last one, you have 37 divided by 10 to the power of 3. Okay, so if you do this, it will be let's divide this. We have 37. Okay, so when you, and the decimal point is here, you can write it as 37.0. So if you divide by power of 3, so the decimal point has to shift backwards. So from here, you have 1, 2 and 3. So the decimal point will be here. So you can fill up this with a 0. So this will be equivalent to 0.037. Okay, so let's erase this, and you can say this is the same as 0.037. Okay, so this is what you have here if you divide by 10 to the power of 3. Okay, so if you want to write this in this form, so that means you start from here. Okay, so this is 37. You have 1, 2 and 3. So this will be 37 times 10 to the power of negative 3. Okay, so you check this. Okay, so I only use this methods, okay, for students that are struggling to understand the multiplication of these two numbers. Okay, so but if you understand very well, so if you have 37 here and you have two zeros here, so that means you have to have 1 here. You shift it once, that is 37. Then you are multiplying by two zeros, that is 100. So it will be 3. That will be 37 times 10 to the power of -3. Okay, you can get this. And for this one too, the same thing. Okay, so this and this, they are the same. Okay, so that is what you should see here. And equally for this, you already have 37. So if you shift the decimal point once, okay, so it's going to be 5 because you already have 4 here. So it's something you can get your answer straight away, but I chose to show you to firstly convert each of these to ordinary form, then now convert each of them to this form. Okay, so let's go to the next question. Question 19. Point A lies on the y-axis and point B lies on the x-axis. M is the midpoint of line AB and P is the midpoint of MB. Find the coordinates of point A and the coordinate of point B. So what we can do here, so let's try to label the coordinates of points A and B respectively. So for point B, okay, so we can say this is the value of x for point B will be x1, comma, then at point B, y is equals to 0, so we can put 0 here. For point A, we have the value of x to be equals to 0, and you can say y is equals to, let's say, y1, okay? So this is what we have here. And for the coordinates of point M, so we can just put x2 and y2 here, okay, just to differentiate the coordinates from one another. Okay, so if you remember very well, there is a formula for midpoint of a line segment. Okay, so ordinarily when you want to get the midpoint of a line, you just have to add the corresponding values of x and divide by 2, and the same thing goes for the y coordinate. That is, for the midpoint, okay, for x2 for instance now, so it will be the addition of, okay, let's just make it general first by writing x here. So it will be equals to x1 plus y1 over 2. So that will give you the s coordinate of the midpoint. And for the y coordinate of the midpoint, it will be y1 plus y2 over 2. So this is the general formula. Okay, now, so let's start with the line segment MB. Okay, so the midpoint is 60 and 11 respectively. Okay, the coordinates of the midpoints P, okay, are 60 and 11 respectively. So that means if you add x1 and x2 together, okay, so x1 plus x2, okay, divided by 2, okay, the answer should be equals to 60. So that is the formula. So that means you can say x1 plus x2 equals to 2 times 60, that is 120. Okay, so this is first thing you should take note. And the same thing for the y coordinates. So you can say here y1, that is 0, you can have 0 plus y2, okay, and that should give you 11. It should give you this, okay, so it should give you okay, let's say over 2, okay, you should get 11. Then you can now simplify this further. 0 add y2 will be y2 equals to 2 times 11, 22. Okay, so that means you're going to have 22 here. Okay, so as easy as that. Okay, so since you know this, don't forget that point M is the midpoint of line AB. So you can do the same thing to get the coordinates of point A as well. That is 0 add y1, okay, 0 add y1 divided by 2, okay, should give you this y2 here, because y2, which is 22, is the y coordinate of the midpoint of line AB. So I can put 22 here. So 0 add y1 will give you y1 equals to 2 times 22. That will give you 44. Okay, so that means the coordinate of point A, okay, are x equals to 0, okay, and y is equals to 44. Okay, x equals to 0, y is equals to 44. So that is what you should get here. So I can put let's say y1 is equals to 44. I can put 44 here. Okay, so equally you can do the same thing, okay, to get the x2. So for x2 now, you have to add 0 to x1, okay, that is 0, that is this, plus the value of x1 here, which we don't know yet, x1, okay, divided by 2, okay, so it should be equals to the value of x2 here, that is the x coordinate of the midpoint of line AB, so you should get x2 here, okay. So of course 0 add x1 will give us x1, okay, over 2 is equals to x2. So once we get the value of x2, okay, so it's easy for us to get x1. So because x1 will be equals to 2 times the answer we get from x2. So let's go back to line MB. Okay, so we need to find the value of x2. So from here, x1 plus x2, okay, divided by 2 should give us 60. So let's write, that's the midpoint. So x1, okay, that is this one here, plus this x2, okay, then divided by 2. So that is the formula for the midpoint of line MB, and the answer should be equals to 60. So that means x1 plus x2, okay, should be equals to 2 times 60, 120. Okay, so then we can now say that x2, so let's make x2 the subject of the formula. So we can say that x2, okay, so will be equals to, yes, we want to find x2. x2 should be equals to 120 minus x. So that would be the formula for x2. Okay, so we can easily put it here now, and that will help us. Okay, so 120 minus x1 rather. Okay, so from here, let's go down a little bit. So we have x1 to be equals to 2 into bracket x2. So x2 is equals to 120, okay, minus x1, okay. So let's open the bracket. So to be x1 to be equals to 2 times 120. So that will be 240. Then 2 times minus x1, that will be minus 2x1. So we can now rearrange to be x1 add 2x1, okay, by taking 2x1 to the left hand side equals to 240. Okay, so we have this add this, that will give you 3x1, then to be equals to 240. So you divide both sides by 3, so that implies that x1 is equals to 240 divided by 3. So 3 goes in 24 8 times, okay, then 3 goes in 0 time, okay, so you have 80. Okay, so x1 is equals to 80. So from here you can see that the coordinate of point B will be equals to 80, 0. So for point B, 80, 0. Then for point A, so we have 0, 44. So 0, 44. So that is what you need to do there. So let's go to the next question. That will be question 20. X is an integer and 1 is less than cube root of x. Cube root of x is less than 2. Complete these sentences about x. Okay, so you need to test this expression here with some values of x. Okay, so when x equals to 1, so cube root of 1 is 1. So of course 1 is not less than 1, so that means x cannot be 1. So don't forget, x can only be an integer, that is a whole number. Okay, and in this case it just be a positive whole number due to the radical we have here. Okay, so this is the first one. X equals to 1 is invalid. So x equals to 2, that is when x is equals to 2, so we have cube root of 2, okay, so which is 1 point something is more than 1, okay, so 1 is less than the answer we get here, okay, which we don't need to get, but we know that it's more than 1, okay, so and this is not up to 2, is less than 2, so that means x equals to 2, okay, is valid for these inequalities. So when x equals to 3, okay, so it will also work. So 1 will be less than cube root of 3, okay, and then cube root of 3 is not up to 2, okay, because we know that already, okay, so that means it will be true for that. When I don't want to consume your time by going deeply, okay, so how we can get this is when x equals to c, cube root of 8, okay, is 2, okay, so that means cube root of any number that is less than 8 cannot be up to 2. So that is the benchmark I'm using to get all this, okay? So cube root of 8 means a number you multiply by itself 3 times and you get 8. So it's only 2 times 2 times 2 that will give you 8. So cube root of 8 is equals to 2. So cube root of 7 will be less than 2. Cube root of 6 will be less than 2, so, and so on and so forth, okay? So you don't really need your calculator here. Since you know that cube root of 8 is equals to 2, then cube root of any number less than 8 will be less than 2. So 3 is valid. If you go to 4, cube root of 4 will be more than 1. So 1 is less than cube root of 4. Okay, and cube root of 4 is not up to 2, just like I told you. So 4 will be valid, 5 will be valid, 6 will be valid, 7 will be valid, okay? But when x equals to 8, okay, so cube root of 8 is 2, okay? So 1 is less than 2, that is cube root of 8, okay? But cube root of 8 is not less than 2 because cube root of 8 is equals to 2. So that means 8 will be invalid, just like as when 1 is invalid, okay? So since cube root of 8 is invalid, okay, so 9, 10, and so on and so forth will also be invalid, okay, because there will be cube root of 9 and above, okay, will be more than will be greater than 2, okay. So that means one possible value of x is you can pick any one of these. You can pick 2, 3, 4, 5, 6, okay. So let's pick 1. So let's pick 5. Okay, so that will be okay. So there is a total of dash possible values of x. So you have 1, 2, 3, 4, 5, and 6. So we have total of 6 possible values. Okay, so let's go to the next question. That will be question 21. Okay, sorry, that is too much. Okay, point P lies on the line y equals to 5 minus 2x. So the x coordinate of P is a negative integer. Then the y coordinate of P is a prime number. Find the possible pair of coordinates for point P. Okay, so for point P, so the x coordinate should be negative, okay, and the y coordinate should be a prime number, okay, should be prime number, okay. So if y equals to 5 minus 2x is the given equation and P lies on this line, okay, so that means when you substitute the value of this of this coordinate, that is the x and y coordinate, okay, so you should get only one answer. Okay, so what we can do now is to test the value of x. Okay, so maybe -1, -2, -3, -4, and so on and so forth. Okay, so which of these, okay, will give us will give us a prime number for the y coordinate. Okay, so let's try to do this. Okay, so if x is equals to -1, so that means we're going to have y is equals to 5 minus 2 into -1. So let's see what we're going to get here. So this will give us 5 minus 2 times -1, that will be plus 2, so which is equals to 7. Okay, so that means we're going to get this. So it implies that when x is equals to -1, okay, then y is equals to +7. So this meets the conditions here. That is, the x coordinate is -1, okay, which is negative, and the y coordinate is what is +7. Okay, so 7, +7. So 7 is a prime number. So this is one possible coordinate. This is a pair of possible coordinates of x and y. Okay, so let's try another one. When x equals to 2, so it will be y equals to 5 minus 2, okay, into -2. So this will be equals to 5 minus 2 times -2, that will be +4. So y is equals to 9. So that means we're going to have -2 against +9. So 9 is not a prime number, although -2, which is the x coordinate, is negative, but 9 is not a prime number, so we cannot use this coordinate. So you can try another one when it is 3. So you can have this, let's say y is equals to 5 minus 2 into, so x is -3 now. Okay, so this will give us 5 minus 2 times -3, that will be +6. Okay, so if you add this together, you get 11. So that means you have -3 comma +11. So the x coordinate is negative. Okay, this is good, and the y coordinate is a prime number. Okay, so you could as well choose this. Okay, so you can write the coordinate. You can pick this or this. Okay, because according to the condition, the x coordinate of p is negative integer, then the y coordinate of p is a prime number. So you can put this pair or this pair. So x equals to -3, y is equals to 11. So you can try as many as possible, okay, and see the values of x, that the value of -x, okay, that is the negative value of x that gives the corresponding value of y as a prime number. So that is what you need to do. Okay, so let's go to the next question. That will be question 22. So work out 8/9, okay, plus 1 whole 1/3 plus 4 whole 4/5. Okay, so since we have two mixed numbers, this and this, so let's start with this first. Okay, so we need to add these two together. So let's repeat this: 8/9, then 1 whole plus 4 whole, so that will be 5 whole. Okay, then I have 1/3 left here, so let's expand this a little bit, then plus I have 4/5 left here. Okay, so what I want to do now, I want to add 1/3 and 4/5 together. So there are many methods you could use. Okay, so for me, I want to use common denominator. So when they have common denominator, I can easily add the numerators. That is, when I have something like this, 5/9 plus, let's say, 2 over 9. Okay, since they have common denominator, then the answer will surely be 5 add 2 over 9. Okay, so you can only add the numerators directly when they have the same denominator. So that's what I want to do now. So for them to have, for these two fractions, 1 over 3 and 4 over 5 to have common denominator, so I have to multiply the numerator and the denominator of this fraction 1 over 3 by 5. Okay, by this 5, it will be times 5 times 5. So for the same thing should be done to the fraction 4 over 5. I will multiply the numerator and the denominator by this 3 here. Okay, so times 3 times 3. So this will give me 8 over 9. Okay, plus this is 5 whole. So let's keep this. 1 times 5 is 5 over 3 times 5, 15. Then add 4 times 3 is 12. Okay, then over 5 times 3 is 15. Now they have common denominator. Okay, so I can add the numerators directly. So this will give me 8 over 9. Okay, plus 5 whole. Then 5 add 12 over 15. Okay, so this will give me 8 over 9 plus 5 whole. Okay, then 17 over 15. Okay, so this is the same as 8 over 9 plus 5 whole. Now out of 17, so we can see a lot of one lot of 15. So that means we can have plus 1 whole. Then we'll be left with 2 out of 15. So I can simplify this further. So it will be 8 whole. Let's divide this into 2. So it's going to be 8 over 9, okay, plus 5 whole plus 1 whole. That will be 6 whole. Then we're left with 2 over 5. So let's remove this. Okay, so then 2 over 15 rather. So this is what we're going to have here now. So now we can now add these two together. So here we don't have a whole number here, so which is 0, and we have a whole number here which is 6. So we can say 0 plus 6 because we don't have anything here. It is nothing. Okay, so I'm going to have 6 whole here. Then I can now use the same method to add 8 over 9 and then 2 over 15 together. Okay, so let's use common denominator again. So this will be 6 whole. Okay, 8 over 9. So let's multiply the numerator and the denominator of 8 over 9 by 15. Okay, so this will be multiplied by 15. This will be multiplied by 15. Okay, plus 2 over 15 again. So let's multiply the numerator and the denominator by 9. So times 9 and times 9. Okay, so we have 6 whole. So don't forget that calculator is not allowed. So we can quickly do something here. So you have 15 times 8. Okay, so we can use any other method you can use to get the product of 8 and 15. So 5 times 8, 40. You write 0, you keep 4. So 8 times 1 is 8. Okay, so 8 plus the 4 you kept. Okay, so that is 12. So you have 120. Okay, and we can do it bit by bit. We can multiply 8 by 10. That would be 80. Then multiply 8 by 5. Okay, that would be 40. Then you have to add the two answers together. You still get 120. Okay, so you can do it that is, instead of multiplying 8 by 15 directly, so you can firstly multiply 8 okay by 10, then 8 by 5, then you add the two answers together. So this will be 120, then over, so 9 times 15. So you can use this now. You can say 9 times 15. You can firstly do 9 times 10. That would be 90. So out of 15, we have used 10. So we are left with 5. So you can do 9 times 5, which is 45. Okay, so you add your two answers together. So this will give you 135. Okay, and you may want to use this method, that is 15 times 9. Okay, so it's still okay, you still get your answer. 9 times 5, 45. You write 5, you keep 4. 9 times 1, 9. 9 plus the 4 you kept, that is 13. You still have 135. Okay, so that's one thing about mathematics. You have you can always have different or many options. Okay, so 2 times 9 is 18. Okay, over, of course, 15 times 9 is 135, so you don't need to repeat that again. So here we have 6 whole. Now I can directly add 120 to 18 because they have common denominator now. Okay, so 120 add 18, so that will be 138. Okay, then over 135. Okay, so of course this is an improper fraction. It will be the same as 6 whole. So from 135 you can get one lot of 130. From 138 you can get one lot of 135. Okay, so that will be plus 1 whole. So out of 138, so 135 has given us one lot, which is 1 whole. So we are left with 36, 37, 30, just 3 numbers. Okay, we are left with 3. So write 3 over 135. So 6 whole add 1 whole, that will be 7 whole. Okay, now before you write 3 over 135, let's see if 3 can divide 135. So from your rule of divisibility of 3, a number is divisible by 3 if the sum of the digit is divisible by 3. So what is the sum of 135? That will be 1 add 3, that will be 4, 4 add 5, 9. So 9 is divisible by 3. That means 135 is divisible by 3. So let's see, 3 goes in 3 once, so that will be 1 over, so 3 goes in 13, that is 4 times, remainder 1. Okay, so you put it here, that will be 15. 3 goes in 15, that will be 5. Okay, so we have 1 over 45. So 3 over 135 can be reduced to 1 over 45. Sorry, so 1 over 45. Okay, so that is the final answer there. So let's go to the last question. That will be question 23. A square has a side length of x centimeters. Mia enlarges this square by increasing each side length of the square by 200%. A. The side length of an enlarged square measures kx centimeters. Draw a ring around the value of k. So what we need to do is to draw a square, okay, as it makes the solution to be easier. So let's draw a square here. So this is a square, for instance. So currently the square is at 100%. Okay, so it means each of the sides will be at 100% and is given as x, x, and x. So if it is increased, okay, if the side length of the square is increased by 200, so this is what will happen. Okay, so by 100% it will be double this. Okay, you're going to have twice this. Okay, so by another okay, so let's repeat that. Okay, so by 100%, if it is increased by 100%, so this is what we're going to have, something like this. Okay, so sorry, so let's repeat that. You have something like this. Okay, so this will be x. Okay, so by another 100%, so that is going to be 200. So let's draw another one. So this is what we're going to have now. Okay, so that means from here to here will be another 100%, and that will be x. So from here to here will be another 100%, that will be another x. So that means the length of the enlarged square will be 3x centimeters. Okay, so that is what it implies. And x add x add x is 3x. okay, is 3x, and is giving us kx. So by the time you compare x, we cancel x, then we have the value of k to be 3. So this is the correct answer. So find the percentage increase in the area of the square after enlargement. Okay, so we need to find the increase. So the increase will be the difference between the area of the squares, that is before and after enlargement. So the area of the square before enlargement will be x times x. Okay, so that will be x. So we can write area, okay, of the square, although this is not necessary. So before enlargement, okay, before enlargement, so will be equals to x times x, that is x squared, and the area of the square, okay, after enlargement will be equals to 3x times 3x, so that would be 9x squared. So the increase would therefore be 9x squared minus x squared, so this would be 8x squared. Then the percentage increase will be the increase itself, which is 8x squared, divided by the initial area of the square, that is the area of the square before enlargement, that would be x squared, then multiplied by 100%. Okay, so here x will cancel, x squared will cancel x squared, so we have 8 times 100% left, so that will be 800%. So this will be the end of the solution to paper 1. So watch out for the series of videos on paper 2. Until we meet again, have your fingers crossed.